Good day, students. In this clip, we're going to be reviewing two problems on implicit differentiation. So let's go ahead and take a look at question number one. We're to find the y dx of the equation 2e to the y plus x sine y equals the natural logarithm of y. Okay, so we have 2e to the y plus x sine y equals the natural logarithm of y. So what we're doing is we're taking the derivative with respect to y of the entire equation. Okay, so in order to do this, we need to know some the derivatives of some functions. Remember e to the x prime as e to the x. Also, the derivative of sine x. Sine x prime is cosine x. And the derivative of the natural logarithmic function, ln x, is 1 over x. Okay, so let's keep these facts in mind. So when we differentiate the first term, we're going to have factor out of 2. Derivative of e to the y is e to the y. Derivative of y is just 1. Using it, since we're differentiating with respect to a different variable, we'll have dy dx. So d of the variable of the term we're differentiating, dx, which is what we're differentiating with respect to. Okay, now x and y, we have a product of two functions, u and v. So this is u, and this right here is v. Okay, we know what the product rule is. So if you have u, let's do that in blue. The uv prime, the derivative of a product of two functions, it's going to be vu prime plus uv prime. All right, so let's go ahead and do that here. We have v, which is sine y. V u prime, the derivative of x, is just 1 plus, let's put a parenthesis here. This is v u prime plus u, which is x, times the derivative of sine. The derivative of sine is cosine, so it's cosine y. Derivative of y is 1. Since we're differentiating with respect to x, we have to add the y dx. Okay? And then lastly, let's differentiate the right side of the equation. The derivative of ln y is just 1 over y. Derivative of y is 1. With respect to x, we have to append dy dx. Okay? All right. Now let's go ahead and simplify this expression, this equation that we have. So we have 2e to the y dy dx plus sine y plus x cosine y dy dx. Okay, and that's equal to 1 over y dy dx. Okay, so this is just like solving an algebraic equation with variables on both sides. In this equation, we want to solve for dy dx. Okay, so these three terms with dy dx, we have to collect them to the same side of the equation, factor out dy dx, and solve. Okay, so let's collect these three terms to the left side of the equation. Okay, so we're going to have 2e to the y dy dx plus x cosine y dy dx minus 1 over y dy dx, and then we can subtract sine y from both sides, equals negative sine y. Alright, so what we're going to do now is factor out dy dx from all three terms, so that yields dy dx times 2e to the y plus x cosine y minus 1 over y. Okay, now to get the y dx isolated, what we're going to do is divide both sides by this quantity that has been multiplied by e to the y. Okay, so we're going to divide by 2e to the y. I mean, that's being multiplied by dy dx. Okay, x cosine y minus 1 over y. And then over here we have 2e to the y plus x cosine y minus 1 over y. Okay, so this divides out. And our final answer, the derivative of that implicit function, implicit equation, is equal to negative sine y divided by 2e to the y plus x cosine y minus 1 over y. All right, so that's your final result. All right, let's take a look at question 2. In this problem, we're going to be applying implicit differentiation in finding the slope, the equation of a tangent line and also the normal line to a curve. Okay, so if we want to write down the equation of the tangent line, let's call it L of x. The equation of our tangent line is going to be f of a plus f prime of a times x minus a. Okay, so this is the same thing as y equals y1 plus mx minus x1. All right, and then let's call, so this one we'll call our tangent line. And then our normal line, let's just call that n of x, okay? Our normal line is going to be f of a plus, now the relationship between the tangent line and the normal line is that you take the negative reciprocal of the slope of the tangent line, and that will be the slope of your normal line, okay? So this is my normal line. So we can see in order to write down the equation of the two lines, we just simply need three things. We need a, f of a, and the slope, okay? Just like you need a point and the slope to write equation of a line, that's what we need here, all right? So remember your point is a and f of a, okay? So a is -1, f of a is 0, which is f of -1, of course. Now, what we need is f prime of a. What is the slope when a is equal to -1? That's what we're looking for. So we need to use calculus here, since that's the only tool that can enable us to find a slope with just one point. Okay, so we have the equation x squared minus xy equals x to the third. We need to find find dy dx when this equation, when its slope is evaluated at the point -1, 0. Okay, so first thing we have to do is find the derivative of this equation with respect to x. So we have x squared minus xy equals x to the third. So we're going to find the derivative, okay? So let's find ddx of this entire equation. Now if we do so, we're going to have derivative of x squared is 2x. If you differentiate, x is just 1. Dx cancels out. So we have that minus. Now we have to use the product rule here. We already went over that. So this is u and this is v. So we're going to use the product rule. Let's write that on the side here. uv prime is equal to v u prime plus uv prime. All right. So we have v, which is y, times u prime, which is 1. Now this minus gets distributed to that plus, so we have minus uv prime. So x times the derivative of y is just 1. Since we're differentiating with respect to y, x, we have dy dx. Okay, and then that equals the derivative of x to the third is 3x squared using the power rule. Okay, so if we want to get dy dx isolated, we're just going to have dy dx equals 3x squared we subtract 2x from both sides and add y to both sides, okay? And then we have a negative x coefficient there, so we're going to divide both sides of the equation by negative x. So it will end up with negative x on the bottom. Now we are supposed to find the slope at a point, so divide the x at the point, negative 1, 0. We're just simply going to plug in negative 1 and 0 into the x and y's in this equation, okay? If we do so, we're going to have 3 times negative 1 squared minus 2 times negative 1 plus 0, and that entire expression divided by the opposite of negative 1. All right, let's go ahead and simplify that. We're going to have negative 1 squared is 1 times 3 is 3 plus 2 over 1, which is 5. That's divide the x at negative 1, 0. Okay, so now we know what f prime of a is. Okay, so remember a is negative 1, f of a is 0. Now f prime of a is 5. So let's go ahead and write down our equations. So tangent line L of x is f of a, which is 0, plus f prime of a, which is 5 times x minus a, minus 1 is plus 1. Okay? And then this is tangent line. And then for the normal line, we have f of a, 0 plus the negative reciprocal of f prime, which is negative 1 over 5, times x minus a, minus 1 plus 1. And that's the equation of our normal line. All right, so that's that. Thanks so much for taking the time to watch this presentation. Feel free to subscribe to our channel for updates to other cool tutorials such as this. And if you have any questions or comments, feel free to post it in the comments section. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day.